Life as we know it has existed on Earth for about 4 billion years. But what if its story began far earlier, perhaps even right after the Big Bang? What if the seeds of life are scattered throughout the cosmos, waiting for the right conditions to bloom? Imagine a universe teeming with alien life, from tiny microbes to advanced civilizations. In today's video, we'll explore a fascinating idea, the possibility that life began not on Earth, but somewhere in the vast expanse of space. Let's dive in. For hundreds of millions of years, Earth was a violent molten wasteland bombarded by asteroids. The surface was a chaotic landscape of erupting volcanoes and flowing lava, creating an inhospitable environment. The planet was constantly reshaped by these cataclysmic events, making it seem unlikely that life could ever take hold. Yet, amidst this turmoil, the building blocks of life were forming. The intense heat and energy from these events contributed to the creation of complex organic molecules, the precursors to life. But as soon as the chaos subsided, something incredible happened. Life emerged. The planet began to cool and the violent eruptions became less frequent. This allowed for a more stable environment where life could begin to take root. The first signs of life appeared in the form of simple, single-celled organisms. These early life forms were incredibly resilient, able to survive in the harsh conditions that still persisted on the young Earth. Microbes quickly filled every available space, from oceans to rocks. These microorganisms were the pioneers of life on Earth, thriving in environments that would be deadly to most modern life forms. They played a crucial role in transforming the planet, contributing to the formation of the atmosphere and the development of more complex life forms. Their ability to adapt and evolve allowed them to colonize a wide range of habitats, from deep-sea vents to the surfaces of rocks. This is strange. Life didn't just appear, it appeared quickly. The rapid emergence of life on Earth is one of the great mysteries of science. How could life develop so rapidly in such a hostile environment? Some scientists believe that life may have originated elsewhere in the universe and was brought to Earth by comets or meteorites. Others suggest that the unique conditions on early Earth provided the perfect environment for life to begin. It's almost as if life was waiting for the perfect moment to awaken. The conditions on early Earth, while harsh, may have been just right for the emergence of life. The presence of water, the right chemical ingredients, and the energy from volcanic activity and sunlight could have created the perfect recipe for life. Once the conditions were right, life seemed to spring into existence almost instantaneously, spreading rapidly across the planet. Even more puzzling is that early life wasn't simple. It was already surprisingly sophisticated. The first life forms were not just simple blobs of organic matter, they were complex, with the ability to reproduce, metabolize, and adapt to their environment. This complexity suggests that the processes that led to the emergence of life were highly efficient and effective. The early microbes had intricate structures and functions that allowed them to thrive in the challenging conditions of early Earth. How could something so complex arise from lifeless matter so fast? This question has puzzled scientists for decades. The transition from non-living to living matter is a profound mystery. Some theories suggest that life began in deep-sea hydrothermal vents, where the right combination of chemicals and energy could have sparked the first living cells. Others propose that life started in shallow pools of water, where organic molecules could concentrate and interact. Despite the different theories, the rapid emergence of life remains a fascinating enigma. The early conditions on Earth were harsh, yet they set the stage for life to flourish. The planet's tumultuous beginnings provided the raw materials and energy needed for life to start. Over time, these early life forms evolved and diversified, leading to the rich tapestry of life we see today. The story of life's emergence on Earth is a testament to the resilience and adaptability of living organisms, and it continues to inspire scientists in their quest to understand the origins of life. Here's the catch. Life, even in its simplest form, requires two incredibly complex things: proteins and a genome. Proteins are the workhorses of the cell, performing a myriad of functions that are essential for life. They act as enzymes to speed up chemical reactions, as structural components to give cells their shape, and as signaling molecules to communicate between different parts of the cell. Without proteins, life as we know it would be impossible. Proteins make life's machinery work, but you need a genome to create proteins. The genome, made up of DNA, contains the instructions for making all the proteins a cell needs. It's like a recipe book, with each gene being a recipe for a different protein. The process of going from a gene to a protein is incredibly complex and involves many steps including transcription and translation. And to create a genome, you need proteins. This creates a paradox. You need proteins to make DNA, but you need DNA to make proteins. This chicken and egg problem is one of the biggest mysteries in the origin of life. Scientists are still trying to understand how the first proteins and genomes could have arisen in the absence of each other. It's like trying to invent the first chicken without an egg, or the first egg without a chicken. This analogy highlights the interdependence of proteins and genomes. Without one, the other cannot exist. This interdependence suggests that the origin of life was not a simple linear process, but rather a complex intertwined one. Crossing this gap from non-living to living should have taken an unimaginable amount of time. The early Earth was a harsh place with volcanic eruptions, meteor impacts, and a lack of oxygen. Despite these challenges, life somehow managed to emerge. The first organisms were likely simple, single-celled organisms that could survive in these extreme conditions, but somehow, Earth's first organisms managed it in a cosmic blink of an eye. The fossil record shows that life appeared relatively quickly after the Earth cooled enough to support it. This rapid emergence of life suggests that the conditions on early Earth were just right for life to begin. It also suggests that life might be more common in the universe than we think. The intricate dance between proteins and genomes is a testament to the complexity of early life. This dance is still happening in every living cell today, a reminder of the incredible journey that life has taken from its humble beginnings to the present day. Understanding this dance is key to understanding the origin of life and the potential for life elsewhere in the universe. As life evolved, it didn't just get more complex, it did so at a predictable pace. Imagine genomes as the blueprints of life. Over billions of years, these blueprints doubled in size repeatedly, from simple microbes to fish, dinosaurs, and eventually us. When scientists traced this clock backward, they found something astonishing. Life's evolutionary journey might have started 10 billion years ago, long before Earth even existed. If that's true, life didn't originate here. It started somewhere out there and traveled to Earth, ready to thrive. This evolutionary clock, with genomes doubling, offers a glimpse into our cosmic origins. What if the entire universe, not just Earth, was once habitable? Imagine a time when the cosmos was a vast, warm ocean of potential, teeming with the building blocks of life. This idea might seem far-fetched, but let's delve into the early moments of our universe to explore this fascinating possibility. Shortly after the Big Bang, the cosmos was hot but rapidly cooling. The universe began as an incredibly dense and hot singularity, which then expanded and cooled over time. This cooling process was crucial, as it allowed the formation of the first subatomic particles and simple atoms. The universe was a seething cauldron of energy, gradually settling into a more stable state. For a brief window, between 10 and 17 million years after the Big Bang, the temperature of the entire universe ranged between 0 degrees Celsius and 100 degrees Celsius, the perfect range for liquid water. This period is known as the habitable epoch, a time when the conditions were just right for liquid water to exist freely in space. Water, as we know, is essential for life as we understand it. This raises the tantalizing question: could life have begun in this primordial cosmic soup? During this time, stars may have formed in dense regions of the early universe, creating the chemical elements life needs. These first stars, known as population 3 stars, were massive and short-lived, but they played a crucial role in synthesizing heavier elements like carbon, oxygen, and nitrogen. These elements are the building blocks of life, and their creation set the stage for the complex chemistry that would eventually lead to living organisms. Could the first ancestors of life have emerged then, thriving in exotic environments like ammonia seas or methane rivers? It's a captivating thought. While our understanding of life is based on carbon and water, it's possible that life could arise in different forms, utilizing other chemical processes. The early universe was a diverse and dynamic place, with countless environments that could have hosted the first sparks of life. As the universe continued to evolve, these early star systems and planets could have provided the necessary conditions for life to begin. Over billions of years, galaxies formed, stars were born and died, and planets coalesced from the cosmic dust. Each of these processes contributed to the rich tapestry of the universe, creating countless opportunities for life to emerge. The story of our universe is one of constant change and evolution, And within this grand narrative, the seeds of life may have been sown in the most unexpected places. Life's early ancestors might have survived by hitching rides on asteroids or hiding in the warmth of early planets. When the universe cooled and became less hospitable, some forms of life may have gone dormant, waiting for new worlds to wake them up. Could Earth have been one such world? If so, life may not just be an earthly phenomenon, it could be a universal one. There might be countless worlds teeming with microbes, oceans of alien fish, and maybe even intelligent beings, all sharing a common cosmic origin. So, how do we find out? Our solar system holds clues. Mars, with its ancient riverbeds, might have fossilized evidence of past life. The icy moons Europa and Enceladus have underground oceans warmed by their cores, potentially teeming with microbial life. Even Titan, with its methane seas, could host exotic organisms unlike anything we've seen. Discovering even one alien microbe would revolutionize our understanding of life's origins and prove we're part of a larger cosmic story. Life's story may have started billions of years before Earth existed, in a universe that was once full of possibilities. Today, we may be just one branch of a vast cosmic family tree with relatives scattered across the stars. The question is no longer whether we're alone, but how far our cosmic cousins are, and whether we'll meet them someday. The cosmic family tree suggests life could be thriving on other planets, waiting for us to discover them. Do you think life began on Earth or in the stars? Let us know in the comments below. Don't forget to like this video if you enjoyed it and subscribe for more mind-expanding content every day. Together, we'll keep exploring the greatest mysteries of the universe. Hit the notification bell to stay updated. Thanks for watching and see you in the next video.